GitHub Actions is a platform, for GitHub obviously, that allows you to run continuous integration and continuous delivery workflows. Previously, I showed you how to run a simple test script inside of a Docker container. This time, we're going to take that test script and run it inside of a GitHub Actions workflow. But first, let's talk about why you might want to use GitHub Actions. Here's an example of how you might use GitHub Actions. Some event occurs, like you pushing a new commit to your repository or someone else opening a pull request. This triggers one or more workflows to run. A workflow runs in a virtual machine or Docker container and completes any number of jobs. A job is a sequence of events or functions. In our first workflow, we might build and test our project. Once that's done, we could run a second workflow to automatically build and deploy the project. While workflows do not run in any particular order by default and might run in parallel, you can specify dependencies to have, say, the delivery workflow wait for build and test to finish before starting. Let's create our own simple build and test workflow so that you can get an idea of how to work with GitHub Actions. To start, let's create a new repository on GitHub. I'm going to call this C Action Test. Leave everything else as default and let's create this repository. From here, we need to make sure that actions are enabled. So let's go to Settings, go to Actions and General, and make sure that Allow All Actions and Reusable Workflows is selected. So save that if not, and we'll head back to the top level of our repository. Next, we need to clone this repository, so open up a terminal. I'm using git bash, head into wherever you keep your GitHub repositories, and I'm going to clone github.com/myname/cactiontest. It'll warn me that I've cloned an empty repository. That's fine. So I'm just going to go into cactiontest. Once you've cloned that repository, we need to go into that directory. So go into your GitHub directory or wherever you keep these projects. I'm going to go into cactiontest. We need to create a couple of nested directories here. So I'm going to create a new folder, and these have very specific names. So I'm going to call this one .github, and GitHub looks for this directory. So in here, let's create another directory called workflows, and that is plural with an S. Go into here, and we want to create a YAML file. This is going to be myaction.yml. YAML stands for yet another markup language, or YAML ain't markup language, depending on which version you want to go with. Let's open this up. It's a human-readable data, often used for configuration files. It's based on JSON. In fact, it's a superset of JSON. So JSON formatting will work with a YAML reader, and the syntax is similar. You can go to this docs.ansible.com in order to read about the YAML syntax. Here's some YAML basics. Note that lists can be a little different than what you might be used to with JSON. Here, a dictionary is represented with your key:value, similar to JSON. However, lists start with these dashes. And so these key value pairs are underneath this particular list item. Note that in YAML, spacing does matter, much like in Python, so you got to pay attention to the indentation. Let's go back to our YAML file that we're creating here. Comments are with a pound or hashtag. We're going to name our workflow. In this case, I'll just give it my test workflow. Next, we want to define what triggers this event to happen. In this case, anytime a push to the repository happens, we want it to trigger this particular workflow. Notice that I'm using the brackets here. We could list it out. So for example, in addition to push, we could also have a pull request. And that's how we would list them out. We don't need the brackets if it's only one item, but I will leave it here as a reminder that you can list multiple events. Then we want to list out the jobs that this particular workflow will run whenever this event happens. To do that, we use the key jobs, and then we list our jobs under here. Note that any jobs we list will run in parallel by default unless we specify some dependencies. However, within each job, there will be a number of steps, and those will run in sequence. So the very first job we're going to do is just to print something to the screen, like your basic hello world. We need to specify how this job will run or in what environment this job will run. In this case, we're going to run on the latest version of Ubuntu that's supported in GitHub Actions. Note that this is a full virtual machine, unlike a Docker container. You could specify a Docker container here or even supply your own, but it's usually easiest just to specify one of the already existing environments. Next, as I mentioned, we will list out the steps that this job needs to perform, and these will be run in sequence. These steps are usually done with a list, so you'll see this dash here, and I will do space, space, dash, space, just to try to keep everything in line. When you're reading other people's workflow files, you might see some different types of formatting, but usually it's in a structure of a list with the dash, and then indented under here, but sometimes this indentation might be something about there. So just pay attention to that, but note that whenever I run something under here, it's part of this list item. We're going to keep this for now. Let's save this, and we are going to push this to our repository. So I'm going to add all the files. I like to check. Yep, we have my action now included in this repository. Now that we've committed, let's go ahead and push it to our repository. Let's open the repository back up. We'll give it a refresh. And let's go into Actions. You should see Hello Actions here. This is the one that we wrote. Click on that. And the little green check mark says that the action completed successfully. If you click on this, you can see the individual steps that were run. Notice that there is some overhead that happens that we didn't explicitly write, but that's okay. GitHub Actions will do its thing. And here's the part that we wrote. Run echo hello GitHub Actions. It prints it out here, and the job is done, and it will clean up everything for us. So we only have to specify a few things. It will handle all of the setup of the virtual machine or Docker container for us, and it will run all of the steps that we tell it to. If you head to docs.github.com/, I guess your language, I do wonder if I put, /actions, it will take you to your language version of the GitHub Actions documentation. If you go under Learn GitHub Actions, go to Understand GitHub Actions. I recommend reading through this page as it will go over some of the terminology that we just covered. For example, what a workflow is, and we created a specific YAML file for our workflow. Events, things that can trigger our workflow. Jobs, which are multiple things that happen when each event is triggered within a workflow. And then there's also an action, and this is, sometimes you'll see a capital A action to mean an application for GitHub Actions. You can actually bundle up your workflow into an action, and then you can import that action into other actions to create a very modular system, and this is one of the powerful things of GitHub Actions. I also recommend checking out some of the examples here, although some of these might be a little more complex than what we're getting into right now, but once you've tried these basic Hello World ones that I'm showing you, I recommend trying out some of these examples. And then I definitely recommend going to the security guides and reading the security hardening guide. This goes over a lot of best practices that you need to take into account before you really employ GitHub Actions into your continuous integration and continuous delivery system. Be aware that using GitHub Actions might expose parts of your repositories, especially if you're using a private repo publicly. So be very careful about how you use them, and I recommend reading this guide before you put it into production. Now let's go and build an actual continuous testing, I guess as part of a continuous integration workflow, using that Hello World workflow that we just created. In the previous episode, we created our own Docker image. So if we go to Docker Hello Docker, you will want our main.c and test.py. We don't need our Docker file, since we're using virtual machines with GitHub Actions instead of Docker. Let's copy these. We will go back into our projects, go to GitHub, C action test, and we're just going to put these here. I'm sure there are nicer ways to do unit tests when you are setting up project directories, but this is a very basic test. Just a recap from our previous episode, our Python test script imports operating system subprocesses, so this should work just fine on a lot of Linux-based machines, and since we're using Ubuntu, both in the Docker image and in GitHub Actions, this should be fine either way. It compiles our code using GCC. Any errors it runs into, it exits with 1. That's how we will tell the workflow that something has failed. It parses our output. It then runs our program. It captures the output. And of course, any runtime errors it finds, it will also send that to the workflow to let us know that it failed. Because we're capturing the output here, we print it to the console, but you could also check the output if you wanted to, and then fail if something's not working based on a known good output that you're looking for. If everything is passed, we will say exit 0, and that tells GitHub Actions that everything succeeded. If we take a look at our main.c, this should look very simple. It's just hello world, or hello from C, and it returns 0 to say that it completed successfully. So now that we have our program under test, as well as our Python script to test that program, let's go back into our workflows. Let's open up myaction.yaml, and we are going to modify this now to run our test script. We're going to add a job here. Remember, this runs in parallel with our job here, unless, of course, we write this line where it says needs and the name of the job that it depends on. Once again, we can do this as a list, so if we have multiple jobs this job needs to wait for, we'll say needs, list those out, and in this case, we're saying this job depends on this job, so once say hello completes, this job will then run. Similarly, we'll say this runs on Ubuntu latest. Earlier, I mentioned that we can use actions in our workflow. In this case, GitHub has created this checkout action for us. So let's go check out this repository. So I will copy this. I will open this window for you so you can see this particular repository. So here, if we go to github.com/action/checkout, this is the checkout action. And this is one or more workflows that has been bundled up into an action for us to use in our own workflow. You can read the documentation here, but this allows us to check out our current repository. So by using this action, we can check out our own repository into our virtual machine so that we can run our code. You can find other actions like this that are bundled nicely so that you can put them into your own workflows. From this, we're going to use version 3 of that checkout action. So if we go back to actions, I don't know how much these particular versions match up with the @v3 tag, but I'm looking at the documentation here, checkout v3, and sure enough, here's basic usage. Actions v3, and then any parameters you might need to fill out. But by default, it checks out the branch that you're checking in, but you can always give it a different branch or point to different parts of your repo if you need to. So from there, let's install the necessary packages. Notice that I'm creating list items underneath steps, which is kind of what we did here. However, we're adding a name to each of these steps. So for example, if we wanted to add a name to this step up here, we would need to use a list item like this. And then we would remove the dash from that list item. So now we have this step named say hello, and that step runs this. So this is nested under this list item, and that's what we're doing here, and why you see me using this particular indentation where we've got 2 spaces, dash, space, so that creates 1 tab indentation, and then this item is part of this list. And then these are the actual listed items inside of steps. The run key allows us to run commands on that operating system. Since we're using Ubuntu, that means we can use the apt package manager. We're going to install Build Essential, which is our compiler and build system for C and C++ and some others. And we also need Python 3 to run that script. Just for fun, I'm going to run print working directory so you can see the output of that appear when we use GitHub Actions. And you notice I'm not giving this one a name. This is just part of the list here. There's nothing nested under this. This should print the working directory inside of the virtual machine. And when we check out our repository, it should give us test.py and main.c in that directory. So then all we need to do is just call Python 3 and that test script in order to compile and run our code. That's all going to happen in that working directory inside that virtual machine. Let's save this. As before, let's check our Git status. Okay, we added some files and modified some, that's fine. Let's add those. We are going to commit, and we're going to make some message here, adding a test framework. With everything committed, let's go ahead and push that to GitHub. Looks like it's been pushed. We'll go check on this. Let's refresh. Here's main.c and test.py. And it looks like something failed here. What on earth? Aha! There is something wrong with my YAML file on line 18. And remember how I said indentation matters? I wrote this whole thing incorrectly here. I forgot to give it a name, just like this, and so it's completely failing on me. This is a good lesson learned about how indentation actually matters. Now, this job has a name, and under that, it has a dependency and then runs on. So now it looks like the one up here. Great, let's save that. We will add that file, make a commit, and we will push that. So let's refresh, go back to Actions, and notice you have the different runs. The first run here was just the hello world, then we had the failed one. Now we've got the new commit, and you can actually see the different actions. So say hello needs to run, it just ran, and because build and test depends on say hello, it waited for say hello to finish, and you can see that dependency link here. So let's click on this and we can see what's going on here. Uh-oh, something failed. So setting up job, you can see everything here, checking out this repo. So that's the actions checkout action that we saw earlier. It checks out our repo and you can see all the commands it used to make that happen. Installing dependencies comes from this line. And this is where that name actually comes from, install dependencies. We didn't give run pwd a name, so it's just pulling it right from here. It's just guessing at our name. And sure enough, we can see inside of this virtual machine, we are at home, runner, work, C action test, C action test. That's going to be our repository. Then we tried to run our test. Oh, building happened. Fatal error, no such file or directory. So it looks like our Python test script is looking for tests main.c, which is a particular directory. So let's go ahead and open up this. Ah, yes, there is no tests directory. Let's make that the current directory since both of these are in the same directory now. We will save that. And let's try push this again. We'll make our basic commit message and we will push this up. Let's go back to our actions. Here's the new one. And we will wait for this to run. And once again, it looks like something failed here. So, we left out our semicolon, just like we saw in the previous episode, because I didn't put it back in. So this is great learning here, and it shows how this workflow caught a very basic error in my code. Even if you or your team members say that they tested locally, sometimes these things slip through, and having this continuous integration and continuous testing can show you that before you merge pull requests or merge new commits into your repository. And you really don't want it to break things, especially with very simple errors like this, and this helped me catch that. So let's go fix that. Let's open up main.c, and there's the missing semicolon. Let's save that. And we will commit everything back to our repository and push it. From here, let's go back to our actions. Fixed semicolon error, here's the newest commit. And we will wait once again while GitHub runs this workflow. Aha, everything passed. We got both green check marks here, And as you can see, the workflow has the green check mark up here. So if we look at this, we can look at run test, building, running, output hello from C, which is what we expected from our C program. All tests have passed, which comes from our test. And because we exit it with 0 instead of something else, everything ran successfully. If you come back to Actions, you can see all of the commits here. If you come back to the home page, you see a little check mark right here, which shows the status of the workflows from any recent commits. So I can take a look at the details of that, and it takes me back to this page. If you're looking to build your own CI/CD system using GitHub Actions, you can head to github.com/marketplace, go to Actions, and then look for something within here. So for example, maybe you want to make something for Arduino. There's one for linting, which helps make sure your code looks nice. There's one for continuous integration. You can use these in your own workflows like I showed you, or you can use them by themselves. All you need to do is click Use Latest Version, and it will tell you what you need to put inside of your own workflow. There might be some others, especially for folks who write embedded firmware. If you're using something with the STM32, maybe you've built it with the Cube IDE. Here's one that will build your entire Cube IDE project for you. Again, we can use it here. And you can always go take a look at their code for their particular action. I believe all of these are GitHub repositories, public GitHub repositories that you can take a look. I don't know, maybe you'll find a proprietary one every now and then. I hope this helps you get started creating your own GitHub Actions. Automating your testing process can save you a lot of time and energy, especially on larger projects. Good luck and happy hacking!